Hi, hello, and welcome to my new course, OpenCV for Dummies. In this course, we will be dealing with the most popular open source image processing library called OpenCV, and we will be using the OpenCV to manipulate, process, and edit the images. We will be also dealing with machine learning techniques which can be used for face recognition, object recognition, and also optical character recognition. Let's get started. First of all, let's see what exactly is OpenCV. OpenCV actually stands for Open Computer Vision, which actually means open source computer vision based library. So it's the most popular one. You will get more details about this library from the website opencv.org, and here you can get all the details about the OpenCV library, the releases, the events, the platforms it supports, everything you can get from the OpenCV website. It's open source means you can always download the source code of this OpenCV library just in case if you want to edit it or enhance it. You can even contribute to the community where the OpenCV is being maintained. The OpenCV library was originally developed by Intel Corporation. They used this library for image processing, image analysis, and things like that. And we have more than 2,500 optimized algorithms that can be used to manipulate, to process, to edit the images using OpenCV. And since it's being an open source system, more and more optimized algorithms and techniques are being added into the existing OpenCV library. So this is an ever evolving library which you can use in your programs, in your computer applications, in your mobile applications, and any other scientific research where you need pixel by pixel analysis of images. You can use OpenCV for free, and it's the most popular and the best library available for image processing. And one of the major advantages is that it supports different languages. For example, scientific programs may be written in C or CPP or Python, Java, whatever the language you write it, even if it's PHP for web development, you can use OpenCV included in these languages. So it's a language independent or technology independent based library. You can use it, the algorithms or the classes or the features of OpenCV in your applications. In whatever the application you are writing your code, you can use it. The actual OpenCV program is written in C++, but we can easily use wrappers that are included in OpenCV in order to use the OpenCV inside your preferred programming language. Computer vision means computer can see objects, identify it's an object, identify what object is it, and do some calculations or math or maybe some decisions based on the thing, the object, what it is seeing. For example, even if it's like in the example, it's a car or a dog or a horse or a person, or maybe some analytical data from satellite graphs, sales graphs. All these data, computers should be able to recognize what exactly is the data, and is the data worthy of being processed, and it should accurately process the data. And for humans, it's a very easy task. For a 3-year-old baby, he can easily identify a car or a horse or a dog. Even something is approaching, a dog is running to him, he can identify it very easily. But for a computer, even if it's a supercomputer or a quantum computer, identifying, recognizing, analyzing objects is a very cumbersome task. So that's why we have OpenCV to help us. These libraries make things very easy. But still our poor computers are not much of an expert in image recognition, just like we humans. So we have to make it, we have to do some manipulations, we have to do some coding, we have to help the computer to get what exactly it is seeing in that image or in that scene where there will be multiple images. And here are the most common applications of OpenCV. And if you consider some 8 to 10 years back, most of these applications were a kind of a science fiction, where humans coming to computer identifying the human, calling by name. Things like that was seen in Hollywood movies, but now everything is reality. Almost all the points that I mentioned here is a reality. You can see in your smartphones itself. Human-computer interactions means you can go to a computer, you can ask the computer for what you want. The computer will understand what exactly you are trying to convey to him. Object identification is something like the computer should know that there's a valid object that he should look out for in the scene, in the picture that he's having with him. And object recognition is identifying what exactly that object is. And face recognition is exactly like object identification and recognition. The computer should recognize there is a face in the image, and the computer should identify what face is it from the set of data or the lessons or the machine learned data he is having with him. Motion tracking is tracking and predicting the motion of a traveling object. For example, in NASA they will be having a program which can identify the path of a traveling meteor, the next moment where it will be, the velocity of that object, like that. So the set of images, the set of space images from telescopes they are using will be fed into the computer, and the computer will be calculating the trajectory, the speed, and the stuff like that associated with that space object. So this kind of things, even if it's a space object or in an object that's there in the earth, you can use motion tracking. Image processing is what we are actually doing in our, even we will be editing our profile pictures, we will be adding some glow here, some adjustments here and there. So image processing is something like you can take an image, you can edit it, you can make it look in your way, and you can save that image. That's kind of image processing. And also in mobile robotics, for example, in recent drones can actually avoid the obstacles in its path and move along. So they will be analyzing every frame of the image, checking for any obstacles, and they will plan their own path around that obstacle. So these are some of very few of the applications of OpenCV based computer vision. And here's our plan for this course. OpenCV is a dependency based project. We need to have multiple scientific libraries that needs to be installed to have the OpenCV setup. So I recommend you, if you are using your computer, it's okay, no problem, you can install directly in your computer, but I recommend you to use a virtual machine so that we can keep all the dependencies and everything inside a virtual machine, and we can install all the packages inside a virtual. I'm currently preferring Ubuntu Linux as our virtual machine because it's one of my favorite Linux distributions, and we will install all the dependencies that we want inside the Ubuntu virtual machine. And to install the Ubuntu virtual machine, we need to have a host virtual machine software, which is we are going to use is Oracle VirtualBox. So first we have to download Oracle VirtualBox, then we have to install Ubuntu Linux inside this Oracle VirtualBox, and then we'll be installing Python and the required packages that we need to start working with OpenCV. So I'm choosing the combination of Linux, Python and OpenCV because that actually resembles the production environment in most of the cases. Because in most cases, computer vision based technologies will be installed inside the Linux platform. So it almost matches the production environment that you may be using in your career or in your organization after learning this course. And the OpenCV version, the current latest version, will be supporting Python 3, so which is the most latest version of Python programming language. So we will be using OpenCV along with Python 3. And in step 3, which is actually the essential part of this course, we will be using simple examples to learn OpenCV library. We will be loading an image, we will be editing it, we will be manipulating it, we will be flipping it, we will be changing colors, we will be combining. So we will do whatever the thing that the OpenCV library allows us to do inside the image. We will be analyzing the image, the pixel, even the single level pixel of that image. So this will be the most prominent part of our course. And using this OpenCV and other open source libraries available, thanks to many developers who have already contributed to developing open source libraries, we will be implementing face detection and also face recognition. The library will be able to detect faces inside a photograph or a set of faces inside a photograph, and it will be recognizing which person is that using the existing data. And finally, we will be dealing with OCR, that is optical character recognition. OCR is not a new technology, it's already been there. It's been so many years the OCR technology has already been there, but using OpenCV based Tesseract library, OpenCV has been vastly improved nowadays. In many countries, they will be using the image recognition for even identifying your vehicle's registration plates and stuff like automatically reading the captcha. Maybe that's a kind of illegal, but still, OpenCV based OCR, optical character recognition, is very improved nowadays. So we will deal with all these things. So this will be a really good package for you. And let's start with our first step in the next video. Thank you.